All right, guys, good morning. So we spent a couple days now talking about angle relationships, right? We spent a day on complementary, supplementary. We spent 2 days talking about the vertical angle relationships. So now we're going to move on to what happens when two parallel lines are cut by a transversal. So let's talk about what that means. So if we're given these two lines as parallel, transversal is just a line that cuts through them. So here's a transversal. Now, here's what happens. As the transversal is kind of running its course here, it cuts this angle. We'll call that angle A. Now, as it continues to run its course, it cuts another angle. We'll call that angle A also because since the lines are parallel, it actually creates the exact same angle. I'm doing stuff with my hands that obviously you can't see. Unfortunately, that kind of goes a little better over in the classroom, but the nature that the fact that those are parallel lines and parallel lines always stay the same distance apart from each other, that's one of their most important properties, means those angles are going to be equal. And then what we can do after that is we can say, well, this is vertical to the first angle A, so based on what we've done the last couple of days, that's going to be equal. And this is vertical to the second angle A. So all four of these angle A's are all equal. And then I can say, well, when this same transversal came, it cut something I can call angle B. And as it continued cutting, it made the same angle B. Or we can just simply say that since this angle B is supplementary to that angle A, this angle B will also be supplementary to that angle A. And I've got a vertical to angle B, and I've got a vertical to angle B. So what we end up with is we've got 4 angles, not 8 angles, but only 2 unique angles, right? I've got angle B's here, 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 and here. They're all equal. And I've got angle A's here, 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 and here that are all equal. So today we're just working on vocabulary. Tomorrow we're going to start, or the next time we meet, we're going to start actually finding missing angles, and eventually we'll get to it if we have time with algebra also. But today we really want to talk about the vocabulary. And this is going to be important in high school because they're going to expect you to know these things, right? They're going to expect you to say the angles are equal if we were doing yesterday's lesson because they're vertical. And let's get to the vocabulary then so I can start explaining. So you don't need to get this in your notes, but we do need to go over it. So we talked about the line that intersects, right? So if these are my parallel lines, right, that line, the orange line, is my transversal. Corresponding angles are in the same position. We'll go into that in detail with the next couple slides. Alternate interior angles, alternate exterior angles. We'll talk about with the slides. It's just going to make more sense seeing it in context than seeing it in a bunch of text. This is the most important part here, that all of these angle relationships make the angles congruent. So if you're doing something and you're saying these two angles are corresponding and one's acute and one's obtuse, you're wrong. Right? Corresponding angles, alternate interior angles, alternate exterior angles, they have to be the same type of angle, meaning they're both obtuse or they're both acute. And specifically, the angles are congruent. That's why we care about this, that they're congruent. So let's see. And again, the reason we need this in high school is we're not going to say, well, both of these angles are equal. And the teacher's going to say, well, what makes them equal? And you're going to say, well, they're both acute or they're both obtuse, which is going to be true, right? But the reason why that's true is not because they're both obtuse. It's because they're corresponding, because they're alternate interior, because they're alternate exterior. So the corresponding angles are in the same position. So I've got a bank of angles here, and I've got a bank of angles here. And if somebody said to me, describe angle 2, I'd say within my bank of angles 1, 2, 3, and 4, angle 2 is in the top right. It's in the northeast corner. And I would say, well, down here, angle 6 is also in the top right. Therefore, angles 2 and 6, and I'm not going to use full-on angle notation here because it gets a little messy. I'm just going to write it out. Angles 2 and 6 are corresponding angles, therefore they're congruent. And angles 1 and 5 are corresponding angles because they're in the same position, right? They're in the top left corner. And angles 4 and 8 are corresponding angles because they're in the same position. And angles 3 and 7, which I'm sure you could have figured out, right? Yes, they're color-coded, and we will take that away in a couple slides, so we'll have to figure it out on our own. What about over here? All right, well, the whole purpose of this slide versus just doing the last slide and moving on is it doesn't have to be 2 parallel lines. I could have 7 parallel lines. Then I'm going to have, 7 pairs, 7 groups of angles that are the same. So here, I know that 1, 5, and 9 are going to be corresponding. I know that 2, 6, and 10 are going to be corresponding. I know that 4, 8, and 12 are going to be corresponding. I know 3, 7, and 11 are going to be corresponding. All right, let's talk alternate interior angles. So when we say interior, we mean inside the parallel lines. So these are my parallel lines, so I don't care about this. So these are my angles that exist inside the parallel lines. Now alternate generally means opposite. So technically 3 and 4 are alternate interior angles, but they're not the ones that we care about. The ones we care about are the ones that are equal, right? So the ones that are equal are ones that are the same type of angle. So I see that angles 1 and 3, right, they're inside the parallel lines and they're alternate. Alternate means they're on opposite sides of the transversal. So yeah, 3 and 4 are on opposite sides of the transversal and 1 and 2 are on opposite sides, but they're not the ones we care about because they're not equal. So what is one pair of alternate interior angles? We would say angles 1 and 3. What is the other pair of alternate interior angles? We're going to say 2 and 4. And if we figured out what alternate interior angles are, I'm sure most of us can figure out what the alternate exterior angles are. They're the ones on the outside. So again, let's revisit my parallel lines. So I just want the angles that are outside. Those are my exterior angles. And again, I want the ones on different sides of the transversal. That's my transversal. So what's on opposite sides of the transversal? 2 and 4, right? The obtuse angles. They're alternate exterior angles. And so is 1 and 3. That's my other pair. So now is where we get to put it all together. And now it's not color-coded. We take off the training wheels and we have to actually do it on our own. So where are my corresponding angles? Well, in my top left corners are 1 and 5. And what about my top right corners? Well, that would be 4 and 8. What about my bottom left corners? That would be 2 and 6. And what about my bottom right corners? That would be 3 and 7. And most importantly, guys, these relationships make the angles congruent, right? So one of the things, the shortcuts teachers will say is, when we've got this relationship, all the acute angles are equal and all the obtuse angles are equal. And that's true. Now, it's not true once we do this and we throw a little triangle in there, then it kind of throws that out of whack. But in a general sense, yeah, it's true. And we do kind of use those shortcuts sometimes, but we want to understand why. Why is 4 equal to 8? Because they're corresponding angles, right? And because the initial kind of little, not that it was a proof, but what I showed you at the beginning about how the transversal cuts the parallel lines, cuts the same angle. So 4 and 8 are equal because they're corresponding. Let's talk alternate interior, right? So now I'm just focused on inside the parallel lines. So there's my parallel lines. So what are my interior angles? I'm only dealing with 2, 3, 5, and 8. Where's my transversal? Here. I want to jump over the transversal and see which angles are equal. Well, I see 2 and 8 are my acute angles. So those are equal because they are alternate interior angles. And I also see 3 and 5. My obtuse angles are also going to be congruent. What about my exterior angles? Now I'm doing the opposite. I just want the angles that are on the outside. And I still want them to be opposite the transversal. So I'm going to say 1 and 7 are my obtuse angles outside my transversal that are equal. And I'm going to say 4 and 6 are my acute angles that are outside. So that's how we do it by, like I said, taking away the training wheels, getting rid of the color coding, and doing it on our own. All right, so now we're going to do one where we've got a little bit more, right? They want vertical angles and supplementary angles. So let's kind of run the gamut and do everything here. Corresponding, I've got 1 and 5. I've got 2 and 6. I've got 4 and 8. I've got 3 and 7. Alternate interior. All right, so let's get back to those interior angles. So I've got 4 is my obtuse and 6 is my obtuse. And with my acute, I've got my 3 and I've got my 5. Let's talk alternate exterior angle. So I've got my 1 is my acute and my 7 is my acute. And I've got my 2 is my obtuse and my 8 is my obtuse. All right, let's get rid of all this. Let's talk vertical. So I've got 1 and 3. I've got 2 and 4. I've got 6 and 8. I've got 5 and 7. All right, now supplementary. We have a lot of pairs of supplementary angles, right? Any adjacent, right? Adjacent, informally we say next to. Formally, mathematically, we say common side and common vertex, which kind of means the same thing, but just in kind of math speak. Supplementary, we're going to have 8 pairs. Right? I'm not going to write them all out. I can circle them. What's one pair, right? So I do this in class, and someone, a lot of people participate. Say, all right, well, let's do the obvious one, right? 1 and 2. And then someone says 3 and 4. And I say, well, we missed some up there. And someone says, well, 1 and 4 and 2 and 3. And then we say, well, what about 5 and 6? What about 6 and 7? What about 7 and 8? What about 5 and 8? So each of those angles will be a linear pair. And then someone really smart will say, well, what about angles 4 and 5? Aren't they supplementary? And I say, well, yeah, they're supplementary. They're just not adjacent, right? Any pair of acute and obtuse angles, right? 1 and 8, right? What about 5 and 4? I think I said that one already. Let's say 5 and 2. Because we can replace 1 with 5 and vice versa. So there actually are more. Certainly not infinite, but there's more. But in general, if someone asked you to find all the supplementary pairs, we typically take just the ones that are adjacent to each other, so we would take those 8. All right, guys, so we are going to call this, instead of our now try again, we're going to take our classwork and make it our homework. This is not a topic that's in the book. So we're going to do the same thing here. If you need to, you can draw this in your notebook and turn your notebook on its side. That may help you, but I'm thinking we should be able to figure out. So all I need you to do for homework, I could draw out the figure, write down the pairs of corresponding angles. There will be 4. Write out the 2 pairs of alternate interior. Write out the 2 pairs of alternate exterior. And in addition, I want the 4 pairs of vertical angles. And I want the 8 pairs of supplementary angles based on the way that I did them before, okay? I don't want all of them. I want the supplementary angles that are going to be adjacent, all right? This should take you all of about 7-8 minutes. As always, guys, any questions or concerns, you please shoot me a message and we'll talk about it.